Hi, Dr. Revis here with an overview of Chapter 9. In Chapter 9, we're going to review gases. Now, gases is something that we're all familiar with, and perhaps some more than others. But in gases, you'll want to think really common and simple about it, okay? For example, if you have a balloon and you blow up the balloon, that means you're putting more pressure, then the volume expands. Release the balloon, less pressure, the volume goes down. Those are the straightforward concepts you'll be learning. If you heat a hot air balloon, air, it lifts up, okay? Because now the molecules are expanding and they're trying to escape. They hit the top of the balloon and the balloon rises up, okay? So you want to think of those basic concepts that you kind of intuitively know, but to be successful in this, you want to know how to rearrange the equations, okay? And watch for what's constant. When you have an equation and it says something is constant, that means ignore it. Do not show it in your equation. So that's one way to know what the equations are that you'll use. And if you get in the habit of marking each variable in the sentence with what it belongs to, it will actually tell you which equation to use, hint, hint. So label each of your values with a particular variable, and it will tell you what you're looking for, and it'll also tell you which variables are in the equation. So if you have trouble memorizing the equation, it's looking at you writing the problem. Be aware of that. So try that. Okay, you'll want to look at stoichiometry, which you already know about, right? You will learn about how to take the stoichiometry and determine moles and reactions. And the key is to remember, if it talks about grams, that's really moles. You got it? If it talks about moles, you can get to grams. If it talks about molar mass, you need moles. So moles will be a key factor or key variable when it comes to talking about molar mass and grams in these calculations. Keep that in mind as well. Then you talk about effusion and diffusion of gas. The only difference is how fast. Okay, and you'll see that in the equation. The formulas are the same, except one does it by time and the other does it by rate. So you have diffusion and effusion. Diffusion, okay, basically means it just goes from one side to the other. It's free to go. Effusion means it's not free to go, but it'll find a pinhole or it will find a way to go through, and therefore time is the variable in that one. In the case of diffusion, it's free to go, and rate, R, will be in that calculation. So you'll know to use the R equation for diffusion because it involves simply free path. In the case of effusion, it's not a free path and it requires time. Then you look at kinetic molecular theory. All of this is summarized as a kinetic molecular theory. And the bottom line is gases move very fast, and they're moving faster when they're hot and slower when they're cold. Okay? They're closer together when they're cold. They're farther apart when they're hot. Then you have non-ideal behavior, meaning that gases don't quite always respond the way we expect them to by what's called the ideal gas law. And so you have these fudge factors, these adjustment variables that you have to add, which will be constants that you simply look up on tables. The key to doing this is following the formulas, labeling all the variables properly according to the values you have in the equation, and put them in and punch it through. But do not forget your units, particularly when it comes to R. You will see an R factor in here, and you'll know what that means. You must pay close attention to the units. Pressures must be in the same units, volume same units, and they must match against R. Keep that in mind. That is perhaps the most common mistake, is that students forget to pay really close attention to the units. All right? So I hope that helps a little bit, get you going with Chapter 9 on gases. Take care.